Welcome to our second video on practical investigation and data analysis skills development for Year 10s. In this video, we are going to look at how you actually display your graphical information. So in the last video, we looked at tables and those two types of data, our quantitative and our qualitative. Now we're going to look at how we decide which graph we're going to use. Very briefly, okay, and we'll be applying this further in class. So once a table of data has been completed and you need your good table of data, okay, the next step is almost always to produce a graph of the data. Graphs have the advantage of being able to clearly show the links between data, although sometimes graphs also show us that there is actually no link between our data. Okay, so as we very quickly touched on in the last video, there are so many different types of graphs out there, okay, and if you're using Excel, you open your little Excel insert graph and it gives you a whole range of options. And the problem with human nature is we tend to move towards the one that looks prettiest or nicest, but not always the one that is scientifically and mathematically correct for what we are actually trying to display. So some problems with graphs. There are so many types. Just look at that image there. There are so many different types of graphs. Each type has its own purpose and use. You need to know those purposes and uses before you use them. So don't choose a graph that you don't know its purpose or use for. Many people don't understand these differences. Do you? And I'm guessing quite a few of you don't, because it is quite tricky to understand which graph you use in which situation. Some graphs can look similar to others, and this can end up giving us misinformation. All right, so we're going to look at a few common graphs that you may need to use. So we're going to look at our bar and column that we've got here, our line and histogram, our pie or donut, and we're going to look at scatter graphs. So first up, looking at our bar and column graph, and I know that quite often you would use these for anything, but these should only be used with qualitative data. So that's where it's not a numerical value that's being used. So for example, in these, the independent variable is actually months of the year, so it's not quantitative data. This is a qualitative variable, okay. Or it can be used for discrete quantitative. So remembering, discrete is the type of data that is a full value, okay, not the 0.5, 0.6. So they are your uses for your bar and column graphs. Okay, line graphs and histograms. These again are only used with qualitative or discrete quantitative data. Okay, so the same as before. Our pie graph or our donut, pie chart, whatever you want to call it. Now these you use with quantitative data, but it's once you've got it into a percentage or fraction form, okay, and then it shows comparisons. All right, then we have our scatter graph, which you can see here. Now a scatter graph is where you actually use the very specific points for each piece of data, and this you can use for qualitative and quantitative data. So any type of data you can display using a scatter graph like this. Here's a question. Would you class this as a line graph? We just looked at this one and said it's a scatter graph, okay? Would this be a line graph? No, because it's got continuous data on it, okay? And because those points are very, very significantly plotted. This is a line graph. So if you're using Excel, it should not look like that. Your graph, if you want a line graph, it should look like that. If you're doing a scatter graph, it would look like that, but that's not a line graph. That's a line graph. So if you're using Excel, that's the line graph. It's really important that you look on Excel at the names of the types of graph. So graphing those variables. First of all, really important to remember our variables. Okay, so we've got that independent variable, that's the factor which you change. The dependent variable is the factor being measured, so I always remember it. The dependent is dependent on the independent. Okay, so the dependent variable changes due to what you're changing in the independent variable. And then we have those control variables, that are all those different factors that must remain constant to ensure that you are carrying out a fair test. Once you have selected the correct graph to produce, because you've just watched the previous video on types of graphs, there is still the task of identifying which data is to be presented on which axes. Okay, so labeling our axis. I've drawn a Cartesian plane here. I'm merging maths and science. Now, the dependent variable always goes on the vertical axis, so the thing that you measured. So if you're measuring how temperature affects plant growth, then the thing that you're measuring is plant growth, so that would go on the vertical axis. The thing that you're changing is the temperature, so that would go on the horizontal axis, which is the independent variable. Now, we call them vertical and horizontal axes in science rather than X and Y. In maths, you call them X and Y, but in science, because we're actually looking at the names of these variables, we're not saying it's 1 on the X. We're saying it's 1 degree, okay? So we don't refer to them as X and Y axis as such, although we are still looking as axis of a graph, the same as we do in math. See you in the next video.